We are used to doing proof by deduction. When we watch a mystery show on television, we are trying to deduce who committed the crime. This is a different type of logic. We are proving things by induction instead. Basically, we have the following three steps. We show a statement is true at the beginning for n equals 1. We then assume that it's true for the first k terms and show that it must be true after that for the k plus first terms. Okay, that's very generic and it goes against our grain. So let's do this for our first problem here. We will be given a true statement and we need to prove that it's true for all values of n. We will not be given a false statement to begin with. So let's begin. Step number 1, show that this is true when n is 1. So let n equals 1. You substitute 1 into the formula on the left to get 6 times 1 minus 4. And we want to determine if that is equal to the formula on the right, 1 times 3 times 1 minus 1. On the left we get 6 minus 4, which is equal to 2. On the right side, we're testing this equality. We have 1 times 3 minus 1. That becomes 1 times 2. And yes, 2 is equal to 2. And we've shown that this statement is true at least for the value n equals 1. Okay, so we've got to start. Now, step 2, we're going to assume that this is true for the first k terms. Basically, that means rewriting the statement at the top here and changing out for the n for a k. So we will have assume that 2 plus 8 plus 14 plus ... plus 6k minus 4, I'll put that in parentheses, is equal to k times 3k minus 1. That is just the original statement with k substituted in for n. Now in step number 3, we need to show that this is true for n equals k plus 1. Okay, let's look at the sum of the first k plus first terms. We know what the sum of the first k terms are, and k is a variable representing the kth term. So let's change this out to k plus 1 because we're going up to k plus 1 terms instead of k. We will have k plus 1 times 3 times k plus 1 minus 1. All I basically did here was change out each of these k's for k plus 1. Now let's clean up this expression. This is going to equal k plus 1 times 3k plus 3 minus 1, which is k plus 1 times 3k plus 2. That is an expression for the sum of the first k plus 1 terms. Now let's actually find s sub k plus 1 another way, by adding up the actual terms. This is 2 plus 8 plus 14 plus ... plus, and this turns into 6 times k minus 4. There's our kth term. And now adding on the next term, this will be 6 times k plus 1 minus 4. That is the k plus first term being added on. Now, we already have assumed up above that from 2 up to 6k minus 4 adds up to k times 3k minus 1. In other words, down below here, we know that everything I've just drawn a red line under adds up to k times 3k minus 1. All we're doing now is adding on the k plus first term, which is what we have here, which becomes 6k plus 6 minus 4. We have 3k squared minus k plus 6k, and I'll make this plus 2. And if we combine like terms, this is going to equal 3k squared plus 5k plus 2. Factoring this, we will then have k plus 1 times 3k plus 2. Now we have shown in two different ways what s sub k plus 1 is equal to, and that basically finishes our proof.